Children, now we are going to learn about electrochemical principle of metallurgy. Already in the last class we have learned about thermodynamic principle of metallurgy. For example, some active metals like sodium, potassium, they cannot reduced by coke thermodynamically. It is very difficult to reduce these metals, that is sodium, potassium, active metals. They cannot be reduced by coke thermodynamically. So in that situation, we have to go for the other chance. So since thermodynamically it cannot be possible to reduce, we go for electrochemical principle. Electrochemical principle. So in that situation, we have to take the metal salts in the fused form. Fused form means in the molten state or in solution form, that is in dissolved state. So reduction is carried out through electrolysis or using reducing agent. So further process gives free energy change for this electrolytic process is given by del G naught equal to minus NF E naught. Del G naught, G naught means standard, change in Gibbs free energy, number of electrons involved in the reduction process, F is the Faraday, E naught electrode potential. So here there are two types of metals, highly reactive metals and less reactive metals. For highly reactive metals, E naught value is more negative. So delta G naught negative, NF and E naught is also negative. So negative into negative becomes a positive. If it is a positive value for delta G naught, the reaction is a non-spontaneous one. Non-spontaneous means this reaction will not occur. It is impossible to take place. But in the case of less reactive metals, total EMF value, that is E naught, is a positive value. So delta G naught is equal to negative NF into positive E naught value, totally become positive value only. So if delta G naught is negative value, not positive, negative. If delta G naught is a negative value, it is a spontaneous one, the reaction occurs. This reduction reaction occurs. So when a more reactive metal, for example copper, in solid state, added to the solution containing less reactive metal, for example metal ions, for example Ag+, less reactive metal ions, more active metal. In that situation, the more active metal will get reduced. Cu becomes Cu2 plus and Ag plus becoming Ag. The less reactive metal ions, more reactive metal. Now more reactive metal will go into the solution, get reduced. Similarly, if you are taking zinc, which is a more reactive metal than copper ions, if this is the case, zinc goes to the solution forming zinc ions and copper ions become copper. Here copper is a more active metal, here copper is a less active metal than zinc. So when a more active metal added to a less reactive metal ions, more reactive metal will go into the solution, not the less reactive metal. So here copper is more active, so it goes to the solution. Here copper is less reactive, so instead of this copper, zinc goes into the solution. This is the electrochemical principle of metallurgy.